definitely 3 will come or 4 will come. You should be ready. Okay, let us see. We'll start with the systems. In equation 1 is equivalent to the equation ax is equal to b. So this is our second equation, equation number 2. So in the from the equations above you can see a. What is a? A are the coefficient of x1, x2 and x3. So what are those coefficients? Means beside x what we have? A11, a12, a13, a21, a22, a23, right? A31, A32 and A33. Same way x. What is x, students? They are unknown. What are unknown? X1 is unknown, x2 is unknown and x3 is unknown. Next we will take matrix B. So B are the coefficients, means this B does not contain any x1, x2, x3. They are B1, B2 and B3 values. See that you do it. Okay, reducing the coefficient matrix A to an upper triangular matrix. So we rewrite the augment matrix denoted by A dot B. So we have to write the augment matrix. So what is augment matrix? It is just a combination of A and B. So already we have seen A11, A has elements A11, A12, A13, then A21, A22, A23 and we have A31, A32, A33 and we have dot B, B1, B2 and this is known as augment matrix. The first step you have to write it down. Remember this. You have to write augment matrix. This is augment matrix. First step in the Gauss elimination method. So now we will go with the steps. Please remember the step. Step 1. Use, yes friends, use, just I will take now, very important, I am going to tell you. We have to use step 1 is important step. Use A11. Where is A11? Here is A11. Okay, take this value with the help of A11, make element A21 and A31. So with help of this value you have to make this two values 0. You have to make this 0 only by elementary row transform. Is it clear? So you have to make this to 0. Keep this in your mind. Then you have to write the next augment matrix. You have to rewrite this augment matrix. So you can see first row is fixed. So we can see this is R1, R2, R3. This is you have to fix. So now this is going to become A11, A12, A13 and this is B1 as it is. What will change? Yes, this is 0, this is 0. This will become A22 some value dash, A23 some value dash and then B2 dash. Here we get A32 dash, A33 dash and B3 dash. So we get this value. Now again by using step 2, go to step 2, use A22 dash. So you are going to use this value to make this term 0. So use A22 dash to make the element A22 dash 0. Yes friends, you have to make this element 0. This you will understand when you solve the problem. Okay, how to make 0, that I will tell you. Okay, you make this 0 now. Then again you have to write the augment matrix A B. So this is A11, A12. Please remember R1, R2 and R3 are changed. They have changed. So here you have to fix R1 and R2. So A11, A12, A13, B1 is fixed. Similarly 0, A22 dash is fixed, A23 dash is fixed and B2 dash is fixed. Only will change, this is going to become 0 and this will be A33 double dash and this is B3 double dash. So we have to stop the iteration. Therefore rewrite this equation in the form of matrix in the form of equation. We will get this as A11 x1 plus A12 x2 plus A13 x3 is equal to B1. Then A22 dash x2 plus A23 dash x3 is equal to B2 dash. Next element is A33 double dash x3 is equal to B3 double dash. Okay, then I am going to take this as equation 1 I have taken, so I will take 2, 3 and 4. Okay, is it clear? Now after taking this 2, 3, 4, take equation 4, find x3 by using simple division. So x3 can be written as B3 double dash divided by A33 double dash. After simplifying this, you will get x3. Then go for back substitution and put x3 in equation 3. So when you put x3 in equation 3, you will get, yes, you will get x2. Okay, so next you find x2 value, then put x2 x3 in equation 2, find x1 value. It's just a numerical, you will just understand very easily. You can do this and simplify easily. So you can see, using this method one can easily solve the problem. So quickly you can write down the problem, students. So very simple problem I am going to take today. Example 1 you can take. Solve the following system of equation. by Gauss elimination method. Okay, they have given the equation like this: x1 plus x2 plus x3 plus x4. So this is 4 cross 4 matrix. Next is 2x1 minus x2 plus 2x3 minus x4 is equal to minus 5, and this is 3x1 plus 2x2 plus 3x3 plus 4x4 is equal to 7. Then we have x1 minus 2x2 minus 3x3 plus 2x4 is equal to 5. So they have given 4 cross 4 matrix. You have to solve easily. Yes friends, this is very easy. So I will tell you, first you write, so just you write first augment matrix. This is first step. You have to write A is to B. So first you write down this value. How you will write down this one? Yes, they are the coefficient of x1, x2, x3 and x4. So and B value. So you can see 1 1 1 1 is to 2. So this is A is to B. First you can easily find A value, then you can find it B value. So here nothing is there, means I have taken 1 into 1 into 1 into 1 into. So they are all coefficient of x1, x2, x3 and x4. Then B is outside the equal to. Next coefficient is 2. Here nothing is there, means 1 minus 1, 2 minus 1. So I will write here 2 minus 1, 2 minus 1 is to, yes, third term. You can look at the question, look at the screen, it is minus 5. Next coefficient 3, 2, 3, 4, 7. Okay, just write that numbers as it is, copy down, don't change anything, as it is you have to write it in the matrix form. Okay, that's augment matrix. Next is 1 minus 2 minus 3 2 5. So this is 1 minus 2 minus 3 2 and this is 5. Okay, so you got the matrix now. Now you have to go for transformation. Row transformation is there. Yes, very helpful, very important, easily one can do it. Okay, so I will take R1 fix always R1. Next go for R2. So when you do R2, I want to make this terms 0, this full terms I have to make 0. I will fix R1 as it is. Now when you are going to fix this R1, please remember that this must be a minimum value. So if you take from 1 2 3 1 is minimum, therefore I have kept 1 in the R1 place. Easily I can subtract R2, R3, R4. So I will change R2, R3 and R4 value. So what substitution should I do? Yes, what I do, I will just take R2 minus 2R1. I will multiply 2 for R1. R1 is what? Yes friends, please remember this. This full row is R1. I have to take R1 1 1 1 1 2. R2 I have to take 2 minus 1 2 minus 1 minus 5. R3 is 3 2 3 4 7. R4 is 1 minus 2 minus 3 2 5. They are the elements, row elements. Okay, full row I am to subtract with full row. Then I will go with next element. Okay, here I will take R3 minus 3R1. Then I will go for R4 minus R1, because it is 1 only, so I will not multiply any element, and 1 minus 1 becomes 0. So now you have to simplify this. R2, take the values, subtract the value R2 minus 2R1. So 2 into 2, easily you can get this is 0. Then 2 into 1 is 2. Then this is subtracted with minus 2 minus 2. 1 minus into minus plus. Then this is minus 1 minus 2 minus 3. 2 minus 2 0. Minus 1 minus 2 minus 3 minus 5 minus 4 is minus 9. So therefore this is our next R2. R2 is changed now. R3 I will go. Yes, 1 3 minus 3 0. So look at the R3 and R1. I'm just multiplying everywhere R1 with 3 number. So 3 minus 3 0. So 2 minus 3 minus 1. 3 minus 3 0. 4 minus 3 1. And 7 minus 6 is 1. Just multiply R1 with 3. Okay. So next, here I am not multiplying anything, just subtracting row. R4 minus R. Okay, this is 0. Minus 3, minus 4, 1 and 3. So just for your understanding, I will do just one simplification. So this I will show you how I have made R2 as R2 minus 2 R1. So R2 I will take it as 2 minus 1, 2 minus 1 and this is minus 5. So minus 2 R1. R1 is 1, 1, 1, 1 and this is 2. I have to subtract this. Tell me why I have to do it like that? Because first term I have to make 0. So minus 2 0 is 0. So if we simplify the next term, it is minus 3. Then minus 2 plus 2 0 and this is minus 3 and then I get this 9. So you can do it in calculator very easily, you should get the answer. So same way I have done R3 and R4. So this is how we have to simplify. Okay, now I will put it in the augment matrix. So R1 is fixed, I will no change in R1, 1 1 1 1 and this is 2. Okay, remaining term, this is 0, minus 3 0, minus 3 minus 9. Next term is 0, minus 1 0, 1 1 0, minus 3 minus 4 1 and 3. So just now we can see we have changed R2, R3 and R4. So you can see here R1 remains as it is, R2 is changed, R3 is changed, R4. Now rows are changed. Remember this. Now what I have to make 0. This is my intention to make 0 in Gauss elimination. Next I will make this 0 and I will fix R1 no change, R2 no change, R3 and R4 will change. Okay, what simplification can I make? Yes, I will just take R3 and R3 plus 1 upon 3, R2 I will make, and next is R4, I will make R4 minus R2. So you can see one example I will tell you. So here in this R3 I have kept it as it is, minus 1 0 1 and this is 1, then plus 1 upon 3, 1 upon 3 r2. We can take this minus into minus will become plus, so minus 3 0 minus 3 minus 9. So easily you have to do it in calculator. Minus 1, your minus into minus will become plus 3 into 3 will get cancelled, so 1 is 0. This is 0 only, no change in this, no change in this. So if you multiply and subtract, will get 0 only. Next, here again minus into minus will become plus, 3 will get cancelled, 1 plus 1 will become 2. Next, minus into minus will become plus, 3 1s are 3, 3s are 9, so 3 plus 1 is going to become 4. So this is my new R3. This is R3. Same way R4 is done. So R4, what you will get this value? R4, new R4 will become 0 0 minus 4 4. Just do the subtraction. Okay. So therefore now augment matrix will change. So therefore our new augment matrix is, so everybody must get this augment matrix 1 1 1 1, no change in R1 and no change in R2, 0 minus 3 and minus 3. Only this two values will change, 0 0 0 2 4. This is minus 4 4 12. As I told you that lower triangle must be 0, so I have to make this 0. Am I right? This terms I have to make 0. To make this 0, now our R1 R2 are different, always remember, just interchange this and lower triangle will become 0 automatically. So this is row transformation, you have to do only row transformation. So this answer is 1 1 1 1. This is 2 0 minus 3 0 minus 3 minus 9. Next is 0 0 minus 4 4 12 0 0 0 2, and this is 4. So our new R1 R2 R3 R4 are ready with lower triangle 0. This is elimination method, students. Please remember elimination, you have to eliminate this 0. This is known as elimination. So when you eliminate the lower triangle, yes, you have to make this lower triangle 0. So please remember this, students. When you make this lower triangle 0, we say this is elimination. So this is lower triangle in the matrix is 0. Then this is actually known as Gauss elimination method. Rewrite in the form of equation. So you can see you are going to write it in x1 x2 x3 x4 is equal to what, friends? Is equal to 2, and next minus 3 x2 minus 3 x4. See, 3 is 0, x3 here again see 0, so I will not write it again and again. So next is minus 4 x3 plus 4 x4 is equal to 12, and 2 x4 is equal to 4. So as I told in the method that after solving this, you easily find the value of find x4. So how you will find x4? Take this equation 2, 3, 4 and 5. Take equation 5 and solve x4. So this is 2, x4 is equal to 4, x4 is equal to 4 upon 2, which is equal to 2. Therefore x4 is equal to 2. Right, now substitute, put. Now this is first I have found out. Next, find. Next you can find x4. x2 I will find. Okay, no problem. x2 you can find, or back substitution you can find x3. So put x4 is equal to 2 in equation. Which equation should I put? 4. So put 2, you can see that implies equation 4 is what? 4x3 plus 4x4 is equal to 12. Just put x4 is equal to 2. Okay, no problem. So just put 4x3 plus 4 into 2 is equal to 12. So minus 4x3 is equal to, bring this equation this side. So 12 minus 8 you will get 4 into 2 8. So ultimately you will get this is equal to 4, and therefore x3 is equal to minus 1. You can do it in the calculator, very easily you will get. Now find, same way find x2. So put x4 is equal to 2 in equation 3. So easily you can do the same calculation, students. You have to get x2 is equal to 1. Then find x1. So put x2, x3, x4 in equation 2. Then easily you can see, after you put all the values, x1 is equal to 0. So this is our Gauss elimination. So therefore answer is x1 is equal to 0, x2 is equal to 1, x3 is equal to minus 1, and x4 is equal to 2 is the answer using Gauss elimination